Hey there, networking pros. In this video, we're going to talk about using fiber optic components to extend your local area network into another building, or in a sense, creating campus-wide network. Now, in the last video, we talked about the fiber optic components, and if you didn't see that video, I'll leave a link here for you so you can go see that one first and then come back to this one. In this video, we're going to do a real-world application. So you'll remember I talked about transceivers and fiber optic cable. So in building A, we've got a switch, and this yellow wire right here represents the internet service that comes from the outside world. So everyone in building A has got access to not only each other's network resources, but they've also got access to the internet. Over in building B, we have nothing. All right, so what we could do is get a couple of matched transceivers. So go on one of the popular auction websites, and if you want to buy brand new, that's fine too. I'm a little bit of a believer of using the auction website first just because of the enormous cost savings. So I got a couple of matched SC multi-mode transceivers. And then I also got a 400-foot, let's pretend it's 400 feet. I got a 400-foot multi-mode fiber cable. And then I connect the two buildings with the multi-mode fiber optic cable. So I'm connecting the two transceivers, right? Then the transceivers also have an Ethernet port on them. So if you don't remember that from the last video, I didn't really spend a lot of time talking about it, but see it's got an Ethernet port on it, a copper Ethernet port. I'm going to patch that in to the switch. Now some switches will come with, or you can get switches that come with the transceiver already built into the switch. So the fiber transceiver is already built in. But if you don't have that, you can just get the transceivers, patch them in. I'm going to add a switch to building B where there wasn't one before. Connect the transceiver this way. Voila, I am now sharing network resources, plus don't forget the internet, with all the people in building A and all the people in building B. So if only it were that simple. The elephant in the room here is how do I get this fiber optic cable from building A to building B? There's a couple ways you can do it. In fact, there may be more than two. But it's either to go underground, in other words, exit the building, dig a trench, lay conduit, and then come back out and go into the side of the building. That's one way to do it. The other way you can do it is with an aerial cable. An aerial cable usually involves putting some kind of a reinforcing line in first. You can't just simply run the cable through the air. I mean, you could, but it probably wouldn't last very long. Because what happens is, there's going to be a lot of tension here. The fiber optic cable itself is not designed to endure that tension. So you need to either buy a cable that's got what's known as a messenger wire already built in it, and the messenger wire is like a steel braided cable that takes the stress. Or the other thing you can do, and this is what I've done when I've done the installations, and I'm not an expert, but I've done a couple of these, is I got steel braided cable and I ran it from here, from building A to building B, and then I put one of those flex conduits. They're kind of those 3/4 inch or 1 inch plastic flex pipe conduits. I secured that to the braided cable, and then I pulled the fiber optic cable through that. And there's a few things you need to know if you're going to buy fiber optic cable. Usually, I recommend buying it pre-made. What I mean by pre-made is that the ends are already terminated. It is possible to do terminations yourself. You can buy the kit. The kit is anywhere from $100 to several $100s to take the raw cable and put the ends on it. But in my situation, what I've done is I bought the cable pre-made, and you can get cables pre-made to length. I'm going to show you in a minute on the end of the video some different resources, some pictures and things I want you guys to know about so that you can make wise decisions about purchasing the cable. So those are things to consider. It's easy to do the transceivers. It's easy to buy the cable. It's the tricky part is getting it from building A to building B. Now let's switch over and talk about some of the other things you need to consider.
All right, if you remember, I said you can get pre-made cables to length. Most of the supplier websites, the good ones, usually come with some type of configuration tool where you can go through and say, okay, I need this type of mode cable. I need to put this kind of end on either side. And it's possible you could have a situation where you would have, an SC on one end and an LC on the other, depending on your equipment. And then you can specify the length. Anyway, so you go through this whole exercise here, and finally at the end, it can tally up the price for you. All right, so that's one way to do it. The other thing you can do is look on the auction websites. You may find pre-made 400, 500, 600 foot cables. It's okay to have something that's longer than what you need. You just need to spool up the rest on either end. I'll show you a few pictures from installs I did. I'm not an expert, so some of you who work in outside plant all day long may have lots of criticism. Feel free to share so we can all benefit. This is an aerial installation I did between two industrial buildings that were about 200 feet apart. That orange thing you see going through the middle of the screen, that's that flex conduit I was telling you about. And it is attached to a steel braided cable. And let me zoom in here a little bit. You can see that a little closer. So this guy right here, this is a steel braided cable attached to the building, and then the flex conduit exits the building a few inches below that. There's a bunch of silicone on the other side, or actually on both sides, to seal from weather. And then it's attached to the steel braided cable. These little rectangular things here, those are buckles that secure the cable on either side. And then there's the other end of the cable going into the building. I know it looks like there's another cable there. That's not mine. That was some kind of a aerial cable that the Bell company had run many moons ago, and it didn't even have a messenger wire in it. So, but I left it alone. And then here's some indoor installation. This thick yellow stuff here is actually multi-strand fiber. So I think there was 12 or 6 different strands in there. But anyway, this is armored. That's why it's kind of thick. And this is the way the slack is stored. See how it's in like a donut shape? They make little plastic donuts that you can get to put on the wall to store your slack. And that's common with fiber because, like I said, it's pretty common to get pre-made fiber cables. So you're going to have slack on either end. And when you want to coil up the slack, you want to have that nice wide radius like that. And then this is a breakout box for that same cable. So okay, I guess it was only 3 pair. So it means there's 6 different cable strands. So that's a cable breakout box. It's almost like a patch panel for cable, I guess. And then there's a smaller one. Again, another 3 pair right there. All right, so hope that helps you out. I recommend you do lots and lots of research if you decide to take on this endeavor yourself. And if you're going to run an aerial cable, especially with that steel braided cable, be very careful. All right, thanks so much for watching. See you next time.